Okay, good morning, guys. This is Professor Az. So today we'll talk about the complex numbers. Well, you might see the name and you might think that, well, they are supposed to be very complex, but actually they are not. Okay. But if we just go for the basic definition, so we can say that the numbers of the form a plus bi, where a and b are real numbers. So if you don't know what the real numbers are, you can just see my the video which I made before the complex numbers, and it will give you all the details about the real numbers. Okay, actually you will get familiar with all the type of numbers which we got before reals, like the set of natural numbers, set of integers, fractions, non-fractions. We talk about that. Okay, so we see a kind of strange thing here, which is called I. So the value of this I is square root of -1. So it looks a kind of strange, but you will understand in a moment. This A is called the real part of the complex number C. And this B, this is called the imaginary part. So that's a kind of strange scenario where you see that a number has a real part and the imaginary part. Well, just think about yourself. We have a body, we have a soul. So we have a real part, we have imaginary part. So, well, that's not exactly these numbers are, but just to get some understanding, you can think about that. The strange thing about I is that, for example, if this is the value I, which is equal to square root of -1, if you take square on both sides, you get -1. You say that, well, what about I cubed? So we know that this is going to be I squared times I. So I squared, we just saw that this is equal to -1. And we have I, so we get -I. What about fourth power? So I can say that actually this is I squared times I squared. So this is going to be, I know that I squared is equal to -1. So this is going to be -1 times -1, which is equal to 1. After that, if you note that, it's just the repetition. I to the 5th power, I can say that this is I to the 4th times I. Well, I just learned that I to the 4th power is 1. So actually this is I, which take you back here. I say that, what about I to the 6th power? So I can say that I to the 4 times I squared. I to the 4th is again 1. So this is equal to I squared. So, well, I'm getting this guy. I say that, what about I to the 7th power? So this is I to the 4th times I cubed. So I to the 4th power, we know that this is 1, so we get I cubed. So we get this guy. One more I know that this is I to the fourth power is 1. So this is actually 1 times 1, which is 1. Well, that's what we have here. So we see that actually after a certain number, which is 4, it starts repeating itself. So for example, I say that, well, I want to know that what will be the I to the power 101. How can I calculate that? So I see that all my answers, it does not matter that what power you take, your answer is going to be always plus minus 1 or plus minus I. One of these 4 is going to be your answer. So the easiest method I have seen is you change it into the bundle of 4. So I can say that this is I to the power 100 times I. Now you say that, is it possible that I could change that I to the 4th to the power, which is going to make it 100. So 4 times 4. If you keep on doing that, this is going to be, if you add 4 25 times, you will see that, well, this is actually 100, or you just multiply 25 by 4. This is 100 times I. Now we know that I to the 4th power is 1. 25 times I. So actually this is equal to I. So similarly, you can just imagine that, but again, the best method, the best way is that you change that power into the bundle of 4, because 1 is the easiest to deal with. And then after that, you can just keep on reducing the power, and you will see that your answer is going to be one of these 4 numbers. That's the amazing part about the complex numbers. Okay, now we see that we got familiar with the numbers. Then how can we add or subtract those strange kind of complex numbers? So we assume that we have a complex number z sub 1, and let's call it, for example, 2 plus 3i. By the way, it might be a good idea if I ask a question that 2, we know that this is a real number, so is 2 a complex number according to the definition which we just learned? Well, the answer is yes. It looks like confusing, but it's not. So because we can say that 2 plus 0i. The condition from the definition is that these two guys, they must be real numbers. So we know that 2 is a real number, 0 is a real number, and it also includes I. So we will say that this complex number 2, it has a real part, which is 2, and its imaginary part is 0. Okay, so we can say that this 2, actually, this is a complex number. So from here we can conclude that all the real numbers are complex, but the converse is not true. Because if we have a complex number, it's not necessarily a real number. Okay, let's come back. So we have z sub 1, which is equal to 2 plus 3i. Let's see another complex number, z sub 2. Assume that this is negative 5 plus 6i. And we want to add these two complex numbers. Well, it's very simple. The main rule is your real part will be added to the real part, and your imaginary part will be added to the imaginary part. So it's going to be 2 plus negative 5 plus 3 plus 6i. Now we can simplify it. So 2 minus 5 is negative 3 plus 9i, and we are done. Similarly, if we have to subtract, well, we do the same thing. is going to be 2 minus negative 5 plus 3 minus 6i. So now we can simplify. 2 plus 5 is 7, and 3 minus 6 is negative 3i, and we are done. So if you add or subtract two complex numbers, the rule is very simple, that you add real part into the real part and complex number to the complex part. The same thing is with the subtraction. Now let's see if we have to multiply two complex numbers. Assume that we are using the same complex number. This is 2 plus 3i times negative 5 plus 6i. Well, we can just simply FOIL it. So 2 times negative 5, then 2 times 6i, then 3i times negative 5, and then 3i times 6i. Okay, now we can simplify it. So this is negative 10 plus 12 times I minus 15 times I plus 18 times I squared. So we can simplify further. Negative 10. Okay, this is 12i minus 15i, so this is negative 3i. Now I squared, we have learned that I squared is equal to negative 1. So we can plug in the value of I squared. Okay, so now we got negative 10 minus 3i minus 18. So we have two negatives, negative 10 and negative 18. We can just add them. So negative 28 minus 3i. Well, this is the answer for the product of the two complex numbers. One thing, if you note that when you added two complex numbers, you got a complex number. When you subtracted two complex numbers, you got a complex number. When you multiply two complex numbers, you got complex numbers. Okay, so these are very nice properties of the complex number. But there is a definition which is used, which is very interesting, which is about the conjugate of a complex number. Assume that we have a complex number z, which is a plus bi. So the conjugate of the complex number is going to be a minus bi. Well, keep in mind the change is happening only to the imaginary part of the complex number. The real part is same. So it means that if I have 2, which we just learned that is a complex number as well, then its conjugate is going to be 2, because the change is happening only at the imaginary part. It's not happening to the real part of the complex number. So that's going to be same. So for example, we have a complex number z, which is 1 plus 2i. Then the conjugate is going to be 1 minus 2i. So one result which is very important, that when you multiply a complex number by its conjugate, Okay, now this is a formula which says a minus b times a plus b. We know that this is equal to a squared minus b squared. So we can apply that, or you can just FOIL it. That's still okay. 1 squared minus 2i squared. So this is 1 minus 2 squared is 4 and I squared is -1. We just learned. And this is 1 plus 4, which is equal to 5. Wow. Well, is this a complex number? Yes, we can say that, but we got a real number. So from here, we can conclude that whenever a complex number is multiplied by its conjugate, okay, the interesting part is all the complex numbers, they have a conjugate. Okay, for the real part, well, it's going to be just the real part. But for the complex number, they have a conjugate. And if a complex number is a solution of a polynomial function, then its conjugate is also the solution of that polynomial function, which is amazing. Okay, so we're gonna stop here, and I will see you guys for the next video. Thank you for watching, and have a good one. Bye bye.